So today we're going to learn about scatter plots. This is our first lesson from chapter 3. And up until this point, I think with our graphing, we've mainly done one variable data. Now we're doing bivariate data. So we're going to have an x and a y axis there. We're going to plot the data, look for strategies, look for patterns here. The calculator will do a lot of that for us. And so the first two concepts here is just what we call the two different axes. So I'm going to just show you a picture of what this looks like because I think it'll make more sense that way. So, So we used to call this, remember we used to call this the x-axis, so now we're calling it the explanatory variable. In science, sometimes you call this the independent variable. We're usually choosing the explanatory variable, explanatory variable. We're usually choosing that, and then it kind of predicts the response variable. This is like our y-axis, so response variable. And the response variable, I like to think of it as something that we measure. Sometimes it helps me figure out, so we're kind of using the explanatory variable, which we choose to make a prediction maybe about the response variable, which is something we're usually going to measure. That helps me figure out which one's which sometimes. So that's what it says. Response variable measures an outcome. Explanatory variable may help predict or explain changes. Notice that it does not cause changes. That's actually a very important point which gets confusing. But it doesn't cause it, just makes predictions here. So scatter plot shows a relationship between two quantitative variables. So they have to be both quantitative. And so we label the axis, we scale it, and we plot the values is how we make a scatter plot. So two variables have a positive association. When one goes up, the other one goes up. The negative association, when one goes up, the other one goes down. And then no association, when you don't see any pattern, you can't really make any predictions about stuff. So these are three different scatter plots. The first one there on the top left, you can see that one probably has more of a positive association there. It looks like if you drew a line, it have a positive slope that kind of modeled that data, a linear line. The next one looks to be kind of going down and to the right. I think that has a negative slope to it, a negative association. And then the last one, boy, doesn't have much of anything. So it's just kind of randomly in there. It doesn't seem to have any association at all. So first, kind of like we described, remember shape and center, we went through those things. This is how we describe a scatter plot. So when you have bivariate data, you want to first talk about direction. Again, positive, negative, or no association. You probably heard those terms before. The form, or, so is it linear or nonlinear? That's all we care about. Is it linear or nonlinear? Usually, most of the data we study in APSTAT is linear. We do occasionally see some nonlinear. That means curved. So if you want to think of that as curved, it's nonlinear. Strength, we use words like, instead of calling something weak, sometimes we say moderately weak or moderately strong, and then we might just say strong here. So those are we use that moderate to describe either way, moderately weak or moderately strong. And it's kind of a guessing game. We're trying to, once you get used to it, you can usually kind of figure that out. And unusual features, kind of like outliers, the idea of that, but it's going to be something that falls way outside of the normal pattern. So if there's a linear line there and the point's way far away from that line, for whatever reason, that would be an unusual feature. Always describe both variables in the context of the problem. So the x and the y, talk about what those x and y variables are, the explanatory and the response. What do they represent? Use actual words here. So in this case, this one shows the relationship between SAT, math scores, and the percent of students who take the ACT for the 50 states. So the mean math score there. So describe the association assigned by the scatter plot. So there's a moderately, so if you want to describe this, first you talk about strength. moderately strong. It's not, certainly not super strong or anything. It's maybe moderately strong association. Is it curved, or is it linear or nonlinear? It looks somewhat curved here. It looks like it has a nice curve to it, so maybe nonlinear. If you look back at the other stuff, so we need, we talked about direction, so we need strength. We talked about strength and unusual features here. So the other thing we want to talk about, so we talked about it's negative. I don't know if we mentioned that, but the direction is negative. And then finally, does it have any unusual points? So it does look like it maybe has a point there at like 20, 50. It looks a little unusual, maybe 88 and 465 or something. That point looks also a little bit unusual compared to the rest of the data. So two unusual points that don't fall in the pattern of that curved negative pattern there. So strength, moderately strong. Direction is negative. Nonlinear or curved, I'd accept either one. I prefer nonlinear. And then there's two distinct clusters of points, and there seem to be 2 points that do fall outside of that. So let's try a couple. So let's learn how to do this in your calculator. So get your calculator out, and I'm going to get off of that page. So let me just start a new fresh page. Okay, so no, don't save changes. Okay, so we're going to go to a course list and spreadsheet. At the top, column name, I'm going to call this one Sprint. Oops, S-P-R-I-N-T. And then that one just long for long jump. So Sprint and long. Okay, so we're going to type in the data as it is, 4.541. So I just finished typing in, but I just want to make a point. Sometimes students get to this point and they forget to press enter on that last point. It'll give me a dimension mismatch, the calculator will, if I don't press enter and get out of that cell. So I definitely want your cursor out of those cells, press enter, get out of the cell. And I've typed in all 12 pieces of data for both of them. So of course, to graph this, to do scatter plot, we're going to go to data statistics. For the X, you can hit tab or scroll down here and click. And we have to decide, so which one is the explanatory variable? Which one is making a prediction? And so my thought is sprint time should make some kind of prediction. The faster you go, maybe the longer you can jump is the guess here. I'm not sure if that's true, but that's what we're kind of hoping. So we're going to use sprint as our explanatory variable, and then long as our measured long distance. So it seems like my hypothesis is the faster you go, the longer you jump. Let's see, is that true? So as you sprint, let's see. So as you sprint pretty fast here, it doesn't look like your long jump is improving. It looks like maybe the opposite here. So, so that's what a scatter plot is. We would describe this as maybe moderately strong, negative, linear, does look linear, and doesn't have a lot of unusual points. Maybe the point 5.7, 130 is a little bit unusual, but I don't even think that qualifies. So there's really not a lot of unusual points here. To do an actual regression here, which we're going to have to do, I'm just going to show you now. And so go to actions. Now, analyze, that's what it is. Analyze, you see regression, and you have a choice for mx plus b, which is linear regression. Let's do that. You can see that now we have an equation here and an r squared value. We'll get to that later, but I just want you to see what a regression line looks like. You can see that helps us predict how strong is this. If the points are a little closer to the line, we might say this is strong. But because the points are, not that tight to the line, we might say moderately strong. If they're not even tight at all, we'd say, kind of weak. This is probably moderately strong is what I would describe it as. So I just want you to see what that looks like on there as far as that goes. And so again, make sure to label it. So I didn't label mine, but, well, the calculator kind of labels it. It at least says sprint and long there. But you want to put the units, so sprint in seconds if you draw it on your paper, and long jump in inches. And then label the graph. What is that representing? 40-yard sprint. So stat Olympics. I don't know what you want to call that, but we come up with some kind of a name. Statistics students have an Olympics match here. Okay, so describe the relationship of each of the following. So the scatter plot shows the relationship between years since 1900 and the 100-meter world record time in seconds from 1983 to 2010. So from 1983, I can see that, 2010. So 2009 or somewhere around there, it looks like someone ran a very low time. If I remember right, I think that's Usain Bolt. So that point at the very end there on the right bottom, I think that's Usain Bolt's time in the 100 meters. I think it was at the Olympics. And so let's describe this pattern. So first of all, it's definitely negative, maybe moderately strong. Is it linear? I tend to think it's kind of linear. That one point is the unusual point down there, seems to be the Usain Bolt point. This is what they said, fairly strong, negative, linear relationship between the years. 1900, notice they put it in context, and 100-meter sprint time records. Usain Bolt's 9.58 seconds in 2009 is a clear and unusual point. Again, so we've got that. Great, that's the lesson for today.